Hello everyone. Today we will solve this problem related with the definite integral shown in the picture. As you can see, this integral comes from minus pi to pi of sine of an x divided by 1 plus 2020 at x multiplied by sine of x. And n is a natural number. So we will solve this problem using some properties of integrals and also some properties of successions that we will see on the way. So at first, please consider the following notation. For solving this kind of problems, we have to introduce notation for making it more simple to write. So we will say in. In is the integral that we want to find. Now we know this. How does the number 2020 comes here to play? So the idea here is to use some kind of subsymmetry that this problem has, and comes from the fact that the integration limits are minus pi to pi, so we can like separate them. So what is the idea? The idea is to make minus pi to pi from sine of an x divided by 1 plus 2020 at x multiplied by sine of x dx plus, okay, here given that we will separate them, it cannot be equal to pi, it will be equal to 0. And here from 0 to pi of sine of an x divided by 1 plus 2020 at x multiplied by sine of x, everything by dx. So here we can see that there is not so much change, we just separated. So in order to see any change, then we have to introduce a substitution, a table substitution. Then in this case we have to see something. There is from 0 to pi, and here from minus pi to 0. So why we don't try to make a minus pi to become pi and 0 remains 0? So let's use a simple substitution like y equal to minus x. So y of 0 is 0 as well, and y of minus pi is equal to minus, this is equal to pi. Okay, so we will obtain this the left hand side. So this part we will obtain it is in terms of y. So let me take it. Okay, before continuing, I want you will recall some properties from sine function. Which property exactly? Sine function, sine of x is a function that is a function that fulfills the following property. So, okay, I will put y equal to minus x. Sorry, I will recall what I did previously. Here, remember that instead of pi, we have to minus pi. We have to put pi because under the map y of x, then x changed to minus x. And here 0 remains the same because minus 0 is 0 as well. And here, so sine of m, and instead of x, we will put minus y. So minus y multiplied by dx is equal to minus dy. This is the differentials, and we just replace it here. Minus dy divided by 1 plus 2020 at minus y multiplied by sine of minus y. Okay, here we have seen in a previous video how to deal with this kind of problem. So with the minus signs up here, it just exchange the order of integration. So 0 comes to the down and pi comes to the top. That's all. And now, what is the property I want you will recall? Sine of minus, let's say minus minus c is equal to sine of c. Okay, so we will use this property widely here. How it is, so sine of minus sine of ny. Okay, we use this minus already. Remember, we use this minus from here to exchange the limits of integration of here. So it is dy. Okay, just a little bit change. And here, this is the important part. It will remain the same, this. But here, we will put minus sine of y. Okay, mostly we get the same expression, but we had a problem with minus y. This is not the same expression in that sense. So we're required to do further algebra. How we will do the further algebra? Okay, let's take this expression and let's go to the next whiteboard. Okay, here we will do something. So let me use another color to follow the algebra. So minus is reduced with minus. So integral from 0 to pi of sine ny, sine of ny by dy divided by 1 plus 2020 to minus y multiplied by sine of y. Okay, now let's do some algebra in the denominator. So integral from 0 to pi of sine of ny, and here just recall some properties well known of exponentials, and it changed 2020 to minus y to 1 by divided by 2020 at y multiplied by dy. Again, we will do some, we will just make some algebra, so I will perform it here quickly. So 1 plus 1 2020 at y is equal to 2020 at y plus 1. Okay, let me write this better. Divided by 2020 at y. Okay, we are ready here, so we just replace what we obtained previously. So the same 2020 at y plus 1 divided 2020 at y multiplied by sine of y by dy. Okay, so we obtained another expression that we require to do more algebra. So let me cut and paste this here. So this is equal to integral from 0 to pi 2020 at y divided 1 plus 2020 y by sine of ny divided by sine of y by dy. Okay, so we can write I, the original integral, as the sum dot 0 to pi from 2020 at y divided by 2020 at y plus 1 multiplied by sine of ny divided by sine of y dy plus the integral from 0 to pi from sine of ny divided by 1 plus 2020 y sine y dy. Okay, so this integral was separated into parts. They have the same limit of integration. What does it mean that we can add them? We could see it in a previous video how to add these expressions. In this case, we just you could see here. Originally, I had here x. Yes, I had here x. But I put y. Is any problem from that? No, because it's just a variable. It's just like a name. It doesn't matter. So it doesn't change the value of I. And we can add these expressions now. Here, let me add 2020y divided 2020y plus 1 plus 1 plus 2020y by sine and y divided by sine of y dy. Okay, we require more algebra here. Integral from 0 to pi of. Here they have the same denominator, so we can add the numerators of the fractions. We get finally something really nice. Then at the final, the integral doesn't depend on 2020 at y. Even we could put whatever we wanted. Don't know, like other time pi, anything. The result will be the same. This will be reduced. So we conclude, until now we haven't finished yet. Sadly, no. The problem is more long than we expected. The integral from 0 to pi of sine in y divided sine of y by dy. And I will introduce more notation here. I will put in. What does mean in? In introduce the idea that the integral depends on the value of n. Yes? So how we will attack here? We will attack here nothing something. So it's complicated to find a0. No, it is not. You will see it's like sine of 0 by y divided by sine of y dy. And sine of 0 is the same than 0 divided by sine of y by dy, and this integral is 0 because it's 0 integral of 0. Doesn't matter what is the interval here. In this case is equal to 0. Okay, and I1 is equal to integral 0 to pi of sine of 1 by y is y by sine of y dy, integral 0 to pi of dy. Then this is y 0 to pi. This is pi minus 0. This is pi. Okay, we want to find sine of we want to find I2. We can do the same. We will obtain like sine of 2y, and then we will open it like 2 times cosine of y by sine of y. And okay, sine and sine will reduce each other, and okay, we can do that integral, but this is the problem. Then we will have 3, we will have 4, we will have 5, we will have 6, and so on. So it's possible, it's not so easy to calculate. If we, for example, use that method and we use n equal to, I don't know, like 200, 300, it can be more complicated if we do it directly. But possible, I have not think that way is very well until now. So if you want to show this procedure on the comment section, it will be nice. Even I will learn to. But I will show that one form that comes from properties of sequences that I like most. So what is the idea here? So let's play a little bit. How we will play? Let's play, for example, let's obtain expressions. So the important thing is the numerator. That is good. Let's put, for example, sine of ny minus sine of n minus 1. Oh, sorry. Wait. Yes, what is the idea? This is like the term that we will obtain if we calculate a1 minus an minus an minus 1. Yes, so this expression is related with this. So we will explore. The idea is to explore, not to say, okay, you do this. No, normally the process that I tend to do are more like exploring. If, of course, sometimes you can have the idea in the moment, but in this case, let's explore a little bit. Why I use this approach too? Because, okay, there is one property that maybe you should remember from trigonometry. Sine of A minus sine of B is equal to 2 times cosine of A plus B divided 2 by sine of A minus B divided 2. Okay, so okay, we have this expression. What will happen if we use this? As you can see, specifically, remember that we are playing. We are like doing like trying, just like making trials. So I, in this case, is ny. And b is n minus 1 by y. If you do a minus b divided by 2, this is the term that is related with the sine. So if we do that term, then what will we obtain? So if we calculate this number, we will obtain ny minus n minus 1 y divided by 2. Sorry, there is a little space here. This is y divided 2. What is the problem? We will have in the numerator sine of y divided by 2 divided by sine of y. It will be more complicated now, because now we will create like an integral, but in terms of cosine, like cosine of n minus 1 or something like this. Okay, you can, if we do a plus b is 2n minus 1 by y. So we will obtain something like cosine of 2n minus 1 by y multiplied by sine of y divided by 2 multiplied by 2. Okay, it's a cosine of 2n minus 1 by y. Okay, and this is divided by sine of y. And again, you will have a similar expression. You do some algebra, you separate sine of y as 2 times cosine of y divided by 2 sine of y divided 2, and you will get like cosine of 2n minus 1 divided 2 of y divided cosine of y divided 2. It's not an easy expression, as you can see. It's again, it's another similar integral as we are trying to solve, so maybe that way can be explored, but this is not what I did. Okay, so it seems that I of n minus I of n minus 1 is not a good idea to continue, but let's see now I of n minus I of n minus 2. So in this case, we will obtain expressions like sine of ny, sine of ny multiply n minus 2 by y. This is 2 times cosine of ny plus ny minus 2y. I just expanded the term divided by 2, and this will be multiplied 2 by sine of ny. Okay, sorry, I will move a little bit. I require more space to finish this expression. Sine of ny minus 2y divided 2. So this is 2 times cosine of 2n minus 2 divided by 2 multiplied by y by sine ny minus ny plus 2y divided by 2. Okay, this is 2 times cosine of 2, you can reduce 2 to 2, and this is n minus 1 by y. And this is sine of ny, it's they reduce, and 2 reduce with 2, then this is sine of y. Okay, so what we obtained here, it's interesting because in minus 2 is the integral from 0 to pi of sine of ny divided sine of y dy minus integral from 0 to pi of sine n minus 2y sine of y dy. Okay, let me use another whiteboard to continue. Okay, here sorry. Okay, here we will have integral from 0 to pi of, again, we can join this expression because they have the same limits of integration, sine of n minus 2 by y, and the same denominator, so it helps a lot. And we already know that this is equal to 2 times cosine n minus 1 by y by sine of y divided by sine of y by dy. This is removed, and of course we will suppose that n is bigger than 1 because already we know what is a1 and a0. So n is bigger than 1, it means that n minus 1 is not equal to 0. Then we can integrate this function, and the integral of cosine is 2 times n minus 1 sine of n minus 1 by y from 0 to pi. Okay, and what did we get? We get 2 divided by n minus 1 sine n minus 1 by pi, sine of 0, because 0 by n minus 1 is 0. Okay, already we know this is 0, and also we know that sine is equal to 0 in all the multiples of pi. It means that sine of n minus 1 multiplied by pi is equal to 0. So we will have 0 minus 0, and this is equal to 0. Okay, so we have proved something important. What did we prove? We proved that I of n minus I of n minus 2 is equal to 0. A0, let me remember, this is 0, and a1 is pi. 0 and a1 is equal to pi. So a2 will be equal to a2 minus 2. This is a0. Okay, this is 0. And you will see to a4 is equal to a4 minus 2. This is the same that a2, and this is 0. a6 will be equal to a4 because this function, then it will be equal to 0. And in general you can prove, even you can do it by induction, or we can just deduce it from the pattern that we are observing, that I of 2n is equal to 0. Now a3 is e minus a3 minus 2, that is 2 is equal to 0, so a3 equal to a1 equal to pi, and a5 is the same than a of 5 minus 2. This is a3, this is pi. So again, we can prove by induction, but if we use the pattern that we have observed, then we can deduce that I of 2n plus 1 with an odd natural number is equal to pi. So we can say that if n is an even number, then n will be equal to 0, and if n is an odd number, then I of n will be equal to pi. Let's summarize the result here quickly. So in 0 and pi. 0 if n is even. Yes, for example, even in 0, 2, 4, 6, 8, so on, 2 multiplied by a natural number. And pi if n is odd. It means like 1, 3, 5, 7, 9, 11, and so on. And okay, this shows that we have solved this problem because we're required to find the integral for all the natural numbers. Okay, then thank you so much for listening. Thank you so much for watching this video. I hope if you want to know more about this kind of problems related with integrals, please check the playlist related with integral calculus, where you will see interesting problems like this. And also you could see this problem didn't require so much sophisticated mathematics. It was just some integral calculus that you will learn in your first or second year at college, university, and some properties of trigonometry that people tend to study before. So it's a problem that has basic tools and can be tackled if you have them in mind. Of course, there is some part that require more divergent thinking, and this is related with, for example, observing that I of n minus I of n minus 2 is equal to 0, but this is part of solving problems instead of doing exercise, because here you have to know what to do. You have to understand and try to see how to continue. This is the main idea of solving mathematical problems of this difficulty. Okay, so thank you too much to everybody. Have a good day.